Before we begin creating our own character controllers, we first want to go over a few parameters usable within our C# script that enable us to more effectively control our character's movement. Transform.translate is a process within Unity that will translate an object that the script is attached to in a certain direction over time. It takes in one parameter to make it work, and that is a vector 3. A vector 3 is simply 3 coordinates that refer to the x, the y, and the z axes in our game. So if we wanted our character to move left to right or horizontally, we would use the x-axis to translate our object. So if we have our player starting on this point here, and we move it 4 places on the x-axis, we would move to this point here. So we have translated +4 on the x-axis. Within transform.translate, that would look like a new vector 3, and in our brackets we would make it the x-axis equals 4, and because we're not moving anywhere on the y or the z, we can make these 0. This would mean we move 4 units on the x-axis, 0 on the y, and 0 on the z. Transform.rotate works in a very similar way, but it accesses the rotation aspect of the transform component on our object. So if I have a cube inside of Unity, then my x-axis will be in one direction, my z-axis will be in another, and my y-axis will be moving up and down. So if I use a rotation vector, and I want to rotate around x, then my character will move around like this. If I rotate around the z, I will rotate around, and if I rotate around the y, my character will spin left to right. To be able to change the speed that our player moves within the game without going back to the code, we can then use variables to feed into our vectors. So instead of writing our vector 3 as 5, 0, 0 to move 5 units on the x-axis, we can instead create a float variable, or an integer if we're keeping it whole numbers, called speed, and assign it the value of 5. We can then feed our speed into the vector so that if we change this variable during runtime or in our editor, it will automatically update our vector 3 with the correct value. If we want our player to be able to control this, then we can add in further calculations using input from Unity. When we access input, there are 3 main areas that we can access: get button, get key, and get axes. Input.getButton deals with predefined buttons made within the Unity Input Manager. So for instance, by default, we can use input.getButton jump using a string to refer to the correct button to access the jump button within the Input Manager, and by default, this is the spacebar. If we want to define a particular key, then we can use input.getKey, and we can write key code dot and the identifier for the key we want to press. So if we want the spacebar, we can write space. Input.getAxis refers to the input manager just the same, except this returns an axis so it can return multiple values depending on what is pressed. So the horizontal axis that deals with our left to right movement has a positive and a negative key. The positive moves to the right, and this by default can be the right arrow key or the D key, and the negative button, which moves to the left, can be by default the left or A key. When we press either option, we will return either a 1 or a -1 depending on the input, whether it is negative or positive. So if we want our player to control the movement themselves, then we can still use our speed variable set to 5, but we've also created a new float called h for horizontal. This float is equal to the value of our input.getAxis horizontal. So as we saw before, this will return a 1 or a -1 depending on whether we want to move left or right on our horizontal axes. We then input this into our vector 3 on the x-axis as a multiplication of the two values. So if we're moving to the right and we press the right arrow key, the sum will be 5 multiplied by 1, which equals 5, and as that's positive, it moves to the right on the x-axis. If we however want to move to the left, then we press the left key. The sum now is 5 times -1, which equals -5, and that moves us left on the x-axis. This sort of calculation can be fed into any one of the x, y, and z axes, depending on where you want to move and what way you want to rotate. In this example, we still have our float called speed, which equals 5. We have a float called h, which we equal to the horizontal axis, so left and right, and a float called v, which equals the vertical axis, so up and down. We can then feed all three of these variables into two quick processes that enable our character to move forward and back and rotate left and right. We have transform.translate with a new vector 3, because we aren't using a pre-made variable, of value 0 on the x, 0 on the y, and speed multiplied by v on the z-axis, meaning our character in a 3D space will move forward and back. The second is transform.rotate, again with a new vector 3 because we're not using a pre-made variable, with 0 on the x, 0 on the z, and speed multiplied by horizontal on our y-axis. Returning to the cube example, our transform.translate will move through the z-axis, so our forward and back, and our transform.rotate will rotate around the y-axis, so our character rotates left and right. If we were to have a 2D top-down game, we would want to feed the vertical into our up and down movement, and the horizontal into our left and right movement. So this would equals speed multiplied by h and speed multiplied by v, and we'd be moving along the x and the y axes. If we wanted a 2D side scroller, then again we would use the horizontal for our right and left movement, so this is the h value, but it's on the x-axis, and then we might use a physics rigid body or translating on the y to enable a jump. The benefit of using a rigid body and adding force means we push our player into the air and gravity brings it back down. If we were using a 3D character, then our vertical will move on the z-axis, so through the depth of the scene. Our horizontal could move our x-axis, so left and right, or it could also rotate on the y-axis, so that we rotate our character around the center point.